Okay. So the water cycle, I'm guessing that pretty much everybody has um, run across this at least once. But thought I would at least touch on it since we're talking about groundwater and running water and all that. Um, so similar to the rock cycle, which talks about what processes have to take place in order for any type of rock to become any other type of rock. Water cycle just kind of goes through different processes that water goes through in the environment, as far as changes in state, kind of different forms that it can take. All right, so this is just some vocab. Like I said, it shouldn't take very long at all. All right, so this first term, evaporate. So it's just when a liquid changes state to a gas. So if we're talking about water and using that as an example, this would be going from liquid water to water vapor, which is what's in the air, it's in the atmosphere. Sometimes you hear it referred to as humidity in the weather, when they're talking about the humidity, how much moisture is in the air. So that's evaporate or evaporation, it's just the process of a liquid changing to a gas. And the opposite of evaporate is condense. So this is a gas going to a liquid. So again, if we use water as an example, this would be water vapor condensing back into a liquid, into liquid water. So clouds are a good example. It says water vapor in the air goes higher up in altitude, it gets colder. Once it gets cold enough, then that water vapor condenses into water droplets and forms clouds. Or why the outside of a cold drink, in the summer or pretty much any other time, why it's wet on the outside, because it's cold enough that water vapor in the air condenses back into liquid water on that surface. The next one, precipitate or precipitation. It's kind of the process of that happening. Any kind of water that falls from the sky. So just like in the diagram, if it's rain, sleet, snow, freezing rain, hail, whatever it is, if this water that falls from the sky, it's a form of precipitate. It's a form of precipitation. This next one, suspend. For what we're talking about, you could talk about water being suspended in a cloud. We also talked about the three ways that sediment is moved by running water. So remember, it was in solution, in suspension, or bed load. So when sediment's moved in suspension, because that water is moving, it has kinetic energy, and there's enough kinetic energy that it keeps that sediment suspended. It keeps it, in the water. Once that water slows down or stops moving, then that sediment's going to settle and be deposited. All right, this one, infiltrate. So infiltrate just means to move into something. But for this, we'll talk about water moving into the ground. It means the same thing as if you say the water soaks into the ground. You could say that the water infiltrates the ground. But again, it's just moving into whatever it is. You might hear it in a movie talking about, I don't know, some spy or something needs to infiltrate some super secret crime organization or something like that. But again, it's just something moving into something else. Next one, aquifer. So underground water. Something to remember about the aquifer is that where this water is, it's solid material. It's rock, it's soil, it's all of that stuff. It's not just some huge underground cavern that is filled with water that, you know, if you dig deep enough, you'll find this cavern you can go swim in or whatever. This is solid material. I mean, it's rock. It's just saturated with water. You know, and all those spaces between the sediment, you know, in the aquifer, it's full of water. It's not full of air. And then we have runoff. So this is surface water, and not surface waters in like lakes and streams and oceans and stuff like that. It's on top of the ground. You know, typically you have this after, you know, a large rain or, you know, large snow melt. And it's also something that you usually have when the ground is saturated, so it can't soak up any more water, so it has to go somewhere. So water is going to find a low point. Water's really good at finding the low point. So like in this picture, you can see there's a hill that goes up that right side. So water, you know, runs down that hill and gathers and collects in this low point, this low area. You know, even so much so that, you know, whatever city this is, wherever this is, has installed a storm drain to, you know, drain that water out of there so it doesn't flood and just remain wet all the time. But, you know, the runoff is just that surface water that, you know, is finding some low point and, you know, will eventually, you know, find its way to some sort of a waterway, a creek or a stream or river or whatever. Then the last one is a reservoir. It's essentially a man-made lake. So we dam up a river, and that creates a lake. This one is Hoover Dam, and Lake Mead is the lake that's created. We use it as a place to store water. You can take this water and use it for municipal water supplies. You know, even around Indianapolis, we have a few reservoirs. Over on the west side, we have Eagle Creek. Then up on the northeast side, there's Geist. And then north of Indy, kind of northeast, is Morse Reservoir. So those are all man-made lakes that hold water that, like I said, we use for city water supplies. So the same water that, you know, people go boating and fishing and all that stuff. And it's, you know, processed and cleaned and purified and all that. And then it can become drinking water. So it's a place to store water because, I mean, the amount of water that we need is a lot. So it's a good place to do that. And then to jump back to the very first slide on this diagram, there's this one little thing in here, transpiration. It's pretty minor, but I just thought I'd mention it. Transpiration is when plants give off water. During photosynthesis, you know, plants generate energy in the form of glucose from, you know, the sunlight's energy from, you know, ultraviolet radiation. You know, so they generate glucose, they generate oxygen that they give off, and also water. So plants, you know, do generate some water that, you know, will, you know, evaporate and go into the air and the atmosphere as water vapor. So that's transpiration. That's all that is. So does anyone have any questions, or are there any slides that I need to go back to?